Good day. So today we will take up two topics, DNS and directory. So first let us talk about DNS. The DNS is the short form for domain name system. Okay. Now, so we have seen two kinds of addresses till now. One is that we have seen MAC addresses, or the so called hardware addresses. In case of Ethernet, they are also called Ethernet addresses, which is used in the data link layer for direct communication. Then we have seen IP addresses, which are used for communication between two endpoints, all right, two endpoints in the network, so they may be anywhere in the network. So IP address includes information used for routing. So IP address is what is used for routing. There is a network part and host part, etc. Okay. But then unfortunately these IP addresses are tough for humans to remember. You can remember only a few addresses, and which you basically require for your own configuration, etc. Maybe you need to know your own IP address, your address of your gateway, etc., etc. But then maybe also address of your for your mail server. But then beyond that, if you have to remember IP addresses of other people, it becomes very difficult for human beings to remember this. Okay, and of course they are impossible to guess. But then what humans find it much easier to remember and use are the domain names. So are the names. For example, and the domain names, I mean, you must have come across these domain names because that is what people most of the time, that is what people use in surfing the web. And for a www site, sometimes you can see that you may not, maybe you do not know the name exactly, but you make out 3-4 guesses, maybe make some combination .com, .net, etc. on this side, and this side something which looks maybe Intel this thing. So I'll try intel.com first thing. Okay, maybe if it doesn't work, maybe I'll try a few other things. So we can guess. So and not only we can guess, the other thing is that the most important thing is that it is much easier to remember. So we need remember so many site names, so it's easier for humans to remember. So for this human interface we need, so this is once again, what's the name after all? It is supposed to map to some particular machine or site or whatever, all right. So this is also, in some sense, this is also some kind of an address. So we have a third layer, which is this, which are the domain names. So today we will see how the how we use these domain names. And of course just as in the local area network you require a mapping from IP addresses to MAC addresses, that is done by the ARP protocol, and the reverse MAC address to IP address RARP. Similarly here you need a mechanism for mapping the domain names to IP addresses. That is what this whole scheme of DNS is all about, and maybe sometimes the reverse query also. We will look into this. So the domain name system is usually used to translate a host name into an IP address. Domain names comprise a hierarchy so that names are unique yet easy to remember. Okay. Now this is important. You remember that IP, I mean, if it is to work as an address, this address better be unique, all right, and it better be unique. In order to make it unique, now in the case of, let's say, IP version 4, we run out of IP addresses because we have a limited length. But here you can go easy with the length, because after all these are not to be used in high speed computation, all right, these are to be used only once or twice maybe in a session. So so you can go easy on the length. That means you can allow longer names rather than only 4 bytes, you can use many more bytes, but then this also has to be unique. And what people thought was that if we make a hierarchy of names, which is a logical hierarchy which corresponds with the external world, then not only they will be easier to remember, they will be easier to administer, and of course we can make them unique. So domain names comprise a hierarchy, so that names are unique yet easy to remember. And this is what the hierarchy looks like. So there is a root. From the root we have the top level domains. Okay, so we have edu, com, org, and so on. Finally, in, maybe these are for some. We will come to that. These are for some nations. And then under EMU, there edu, there may be MIT, Albany, and all kinds of other these things. Under in, there may be EARNet and all other kinds of organizations there. And then under these, in MIT also there may be CS or something under MIT. So there is a tree and there is a hierarchy, and this hierarchy is sort of a global hierarchy. This is the DNS hierarchy. So each host name is made up of a sequence of labels separated by periods, as you must be knowing. So each label can be up to 63 characters long. Okay, very long label dot something, something like that. All right. So each label can be up to 63 characters, and the total name can be at most 255 characters. So you have got up to 255 bytes to sort of code these names. So we, as I said, that you can go easy on the length. Examples: whitehouse.gov. All right. Of course, .gov is for government, and it's since it started in USA, it's US government. So and anyway, whitehouse.gov is a domain. Similarly, let us say cac.iitkgp.earnet.in. Okay, and that again is a .in. That in is a top level domain standing for India, and then EARNet is an organization which has got which comes in the next level in, and under EARNet there is IIT KGP which comes in the next level, and under IIT KGP there is CSE which again comes in the next layer. So starting from here you can go from the leaf of the tree right up to the root of the tree, that I mean this tree, the DNS hierarchy tree. So my name is a, and for each, after giving a label at each level we put a dot and then go up to the next level. That is how we name hosts. So the domain name for a host is a sequence of labels that lead from the host to the top of the worldwide naming tree. A domain is a subtree of the worldwide naming tree. So anything, let's say MIT is a domain, ARNet is a domain, and so on. So this is a subtree, and under ARNet of course there will be so many other subdomains. So there are, any domain is a subtree of the worldwide naming tree. A host has a domain name specified using a sequence of names, each of which may be up to 63 characters long, as I mentioned, separated by periods. Names are case sensitive. A domain is an absolute domain name or a fully qualified domain name, FQDN, if it ends with a period. Most generic domains .com, .edu, etc. are international, but there are some like .gov for government and .mil for military. These are US specific. So when you say .gov, it actually means US government, and .mil is for US military. Actually, I mean, if you remember the history of internet, it started in USA from the ARPANET, etc. So it slowly evolved and all that. So at that time it was very US centric. Now of course the whole world has embraced it, so that is there. And then some new top level domains have recently been proposed, okay, although they are not very popular as yet. Countries each have a top level domain, 2-letter domain name. For example, IN for India, JP for Japan, UK, and so on. A system is required to map the domain names to the IP addresses. Okay, and just like we have ARP for IP address to MAC or MAC to IP address, for RARP. Similarly, we need from domain to IP address, that is the chief one, and maybe the reverse one also. Now, for implementing the DNS, we use a distributed database and implemented in a hierarchy of many name servers. So this is distributed. This of course is important to have it distributed because this is used so widely. You cannot have a, I mean, if you had a centralized database, first of all it would be much more difficult to administer this, and secondly it will, I mean, there would be a single point of failure, and thirdly the network traffic at that node would be tremendous. All right, so it would not be able to handle that much network traffic if everybody tries to log into the same one central name server. That is not feasible at all, it does not scale. So it has to be distributed, and the way it is distributed has to do with the way it is administered, and we will mention that later. So, what is distributed are some name servers. So, these name servers are the servers which gives you the mapping from the domain name system to the IP address. So, and there is an application layer protocol, host, routers, name servers, which sort of all combine and communicate to resolve names. Resolve means this address name translation. This is the resolving of names. So, the core internet function, this is a very core internet function which is implemented as application layer protocol, and this complexity at the network's edge, so that the at the network's core where the traffic is very high and very heavy, this does not this is not there, because if you had to do the domain name services at the routers, maybe at the core routers, that would put too much strain on the router. So, they have been put to the edge of the network. Now we talk what is the for this resolving, we use resolvers, and there are full resolvers and stub resolvers. So, the client for this naming system, this is called a resolver. This is transparent to the user usually, and is called by an application to resolve names into real IP addresses or vice versa. So, when you click that means, or when you type in a domain name in your browser, actually that browser of course is a client application program for HTTP. So, it calls the resolver to translate this domain name which you have typed in into the corresponding IP address, so that the browser will send an HTTP request to the web server using that IP address. So, it gets it from the resolver. A full resolver is a program distinct from the user program which forwards all queries to a name server for processing. So, this is what it does, it forwards all queries to a name server. So, it knows about the name server. Responses are cached by the name server for future use, and often by the name server. Of course, a full resolver, I mean, it may so happen, and we will come to the details a bit later, that your names, the local, the full resolver in your machine, in your host, that may connect to the local name server, and the local name server may not have the resolution. So, it is going to contact other name servers and finally get it, and finally you will get the result. So, we will look into the details of this later. So, this is a diagram, you have the user program here, which gives an user query to the full resolver. The full resolver gives this query to a name server. This name server has its own database, so it may look up in the own database. If it is not there, then it may send the request to foreign name servers, and finally it will give a response. And the full resolver also maintains a cache, so it will cache this response, so that in the very next one, if you again ask for the same resolving the same name, it can give you from the cache and also give the user the response. So, this is and of course, name server also maintains its own cache. And somewhat a little bit more limited in functionality is a stub resolver. So, a stub resolver is a routine linked with the user program which forwards the queries to a name server for processing. Responses are cached by the name server, but not usually by the resolver. So, this is one part. So, there are two parts where a stub resolver differs from a full resolver. One is that a full resolver may have a cache, while the stub resolver usually does not. And secondly, a stub resolver has to be linked with the user program, whereas the full resolver is running by itself. So, on Unix, the stub resolver is implemented by two library routines: get the host by name and get the host by address, for converting host names to IP addresses and vice versa. So, these are the routines. So, stub resolver is a part of the user program which sends the query directly. This part of the user program, it gets linked, and this routine sends the query to the local name server and gets the response, and naturally this user program gets it. Now, a little bit about the organization. This is a distributed organization. So, it is a distributed database. The organization that owns a domain name is responsible for running DNS server that can provide the mapping between host names within the domain to IP addresses. So, some machines run by say some organization like RPI is responsible for everything below within the rpi.edu domain. There is one primary server for a domain and typically a number of secondary servers containing replicated databases. So, it is important to understand a little bit about how this is organized. You have to understand that this is a global system. So, which means that this is very, very big. So, any effort to control this centrally would become quite difficult. So, the way it is done is that, so let us say that cac.iitkgp.yarnet.in, let us take this domain. Now, .in is a domain which is for the whole of India, and there is one specific organization, it happens one specific organization in India which looks after this domain. So, whatever subdomains are there under this domain, it is the responsibility of that organization to keep track that who all can be given subdomains, that means who all can be given names within this subdomain in. Alright. So, any name resolution query which is coming from somewhere anywhere else in the world, they will direct their query to first to this organization who is maintaining the domain in, and the domain in, of course, there are so many organizations maintaining their own subdomains under the domain in. So, either they that organization will have it in its cache, or it will forward the query to the particular domain. And now, suppose this way it gives a subdomain to Yarnet. Now, Yarnet again gives a subdomain to IIT-KGP. Now, again under IIT-KGP there may be so many subdomains, but the Yarnet does not really bother, may not bother about whatever subdomains are there under IIT-KGP. It only has to know that IIT-KGP is an organization under Yarnet which has got a name, which has got a separate domain. Now, it is the business of IIT-KGP to decide which all how it is going to break this domain into further subdomains, or it may not break at all, etc. That is IIT-KGP's business. So, this way the entire domain administration is decentralized, and that makes it easy, that is for one thing, and secondly it also makes it easy to make the addresses, these names are also some kind of addresses, to make them unique. The point is that since you have broken them into names which stand for actual organization at any level, naturally you will not have any particular organization which is administering a domain will not have two organizations having the same subdomain name under it naturally. So, it will give different names. So, this way all the names automatically become distinct. So, that is another good advantage. So, we have discussed this: why not centralized DNS, single point of failure, traffic volume, distant centralized database would not work, maintenance would be a problem, it does not scale. So, no server, so it is distributed, no server has all the name to IP address mapping. Local name servers, each ISP company has local name or the default name server, and host query first goes to the local name server. Authoritative name server, this you might come across sometimes that something is being given by authoritative name server. For a host, stores that host's IP address names, can perform name address translation for that host's name. So, and anyway there are some more things up the hierarchy. And there are some root name servers. Okay. So the root name server can, so they are actually, as I said, that this is still mostly US centric, and some of the biggest name servers, root name servers, are all in USA. But of course, I mean that depends on what root it is. So they are, they could be distributed also. NSLOOKUP. NSLOOKUP is an interactive resolver that allows the user to communicate directly with a DNS server. So, from the OS you can use this NSLOOKUP and give a name query. So, this is actually name server lookup, that is how the term NSLOOKUP comes. NSLOOKUP is usually available on Unix workstations. So, servers handle requests for their domain directly. So, we are now let us talk about the servers, and servers handle requests for other domains by contacting remote DNS servers, and servers cache external mappings. If a server has no clue about where to find the address for a host name, it asks the root server. The root server will tell you what name server to contact. A request may get forwarded a few times. For example, let us say the IIT KGP has a name server. All right. Now, if the IIT KGP has a name server and a request for a particular domain name translation has come to it, it does not know the name server to whom to connect. So, it can always transfer it to the next higher level, namely ERNet. And if the ERNet also does not know where in this IN it is there, then it can contact the IN. IN will definitely know all the subdomains under it. It has to know it because it is administering that domain. Similarly, if it is for some address which is from outside, you can send it directly to the root of that particular domain. Say suppose from India you are trying to contact something for Japan. So, you can send it to the JP root name server, and then JP root name server would know which name server to contact. So, that will come back. So, this way DNS queries will go back and forth a few times, and finally the name will be resolved. If a server is asked to provide the mapping for a host outside its domain and the mapping is not in the server cache, the server finds a name server for the target domain. The server asks the name server to provide the host name to IP translation. To find the right name server, once again it can use DNS. A request can indicate that recursion is desired. This tells the server to find out the answer, possibly by contacting other servers. If recursion is not requested, the response may be a list of other name servers to contact. Okay. So, there are two versions of these DNS servers, the recursive server and the iterative server. In the recursive server, what happens, I mean if recursion is requested and that is sort of honored, that request is honored, that means that say I am a name server. So, I will send a request to the name server whom I think may have a clue about how to find this, do this resolution, and a request for recursion. Now, he will make all the other contacts. So, he will make the next level, maybe then another level. So, he will make the contacts which are necessary, and finally the answer he will send me. Or, so this is the recursive version. In the iterative version, what happens is that he will simply give me a list of name servers to whom I can possibly contact directly to find out more. So, then I make some more requests, maybe some more other lists come, then I make some more requests. So, this way it goes. So, this is an example. Suppose this is a recursion is there. So, some host some host. So, 1 it makes a request to the local name server, then the local name server may send it with a request for a recursion to another name server. So, he will now make the necessary request, get the response and then give the response. In the other case, the iterative case, so as the request goes to, then so this is again in this particular case it knew it one shot, but it may not be in one shot, and when recursion is requested this may go deep down, finally find out and then finally send the request. Whereas in the iterated queries, he gives a query, gets some list, he gives it to the next name server, he gets some more response, then he will maybe send it here and get it, or he will get it for you, etc., and finally it will be resolved. So, that is an iterated query, recursive query versus iterated query. And DNS caching and updating of records. Once any name server learns a mapping, it caches the mapping, we have mentioned this. Cache entries time out after some time. So, update or notify mechanisms under design by IETF under some this thing, that how the cache is to be managed. We will just take we will not go into all the details, although they are given in the slide, we will need not have the detail. So, these are the so called resource records or RR, and they are RR, the resource records have a format. Type A is the name is host name and value is IP address, this is the most common one. Type equal to NS, name is domain and value is IP address of authoritative name server for this domain. Type is CNAME, where name is an alias name for some canonical, that is the real name, value is the canonical. Type MX is for mail server records. So, these are the various resource records which are handled by the DNS. And the full this thing is the following, that we have a header followed by some queries, followed by some resource records and some authority records if it is from authoritative name server, and maybe some additional information. So, this is the DNS message format. So, we have in the message header, which is just a 16-bit number. First we have an identification, which is a 16-bit number for query, and reply is also 16 bits. And then we have a number of flags, and we will look at these flags. Let us say QR flag identifying a query 0 or a response is 1. Opcode, it is a 4-bit field for the kind of query. It may be a standard query 0 or inverse query 1 and so on. Then there is a server status, that other values are reserved for future use. AA is authoritative answer, that means this is coming from an authoritative mail server, name server. TC is that response has been truncated. So, if the TC is there, response has been truncated, actually this switches from UDP to TCP, we will see about that. RD is recursion desired, RA is recursion available, etc. R code is some code, return code. Now, both UDP and TCP are used by name server. TCP for transfer of entire database to secondary servers, and UDP for lookup. So, the lookups that we were talking about, they are usually basically they are used they use the UDP protocol, which is a which you have seen, that is a very simple protocol, so no overhead, etc. But there is a limit to the that UDP, and in response to UDP you will get just one packet which will have just 512 bytes. Now, if the response requires more than 512 bytes, which it might, in that case the requester submits request using TCP, resubmits. So, there is a truncated, the message is truncated, that flag is set, and when the client sees that flag, it resubmits. It first of all opens a TCP connection with the corresponding name server, and then just resubmits the request, so that it can get a longer request. This we have already discussed, the administration zones. A zone is a subtree of the DNS tree. that is independently managed. Second level domains, let us say rnet.in, are usually an independent zone. Most subdomains, iitkgp.rnet.in, are also independent. Independent means that what happens under this is of course their business. So, most universities have departmental domains that are then independently administered. Now, a zone must provide multiple name servers. This server records the number, the members of the domain. You typically need a primary name server and one or more secondary name servers. Secondary retrieves information from primary using a zone transfer, using a TCP connection. The reason why this secondary name server is also required, sometimes more than one secondary servers are kept. The reason is that this is so vital for everybody that, I mean, actually suppose you are administering a domain. So, you have now when you are administering a domain and you want to be independent, that means you can create subdomains under you, etc., then you have to maintain your own name server, and you cannot maintain just only one name server. You have to have multiple name servers, so that when the primary name server fails, the secondary can immediately take over. So, from time to time the primary will cache, will learn about things, and from time to time the database will be shifted to the secondary one, so that they remain more or less in sync, so that as soon as the primary goes, the secondary can start acting as the primary and maybe authoritative name server for this particular domain. So, so that is required, and of course, you also have to have, because there will be requests from other people to you for IP addresses in your domain, and you are bound to give that. So, that is why you have to have these different name servers, and of course, also good network connection to handle all these requests. There is a reverse query which is there, and which is sometimes used as a sort of weak protection against some spoofing, we will see. So, this set q is equal to PTR, that is PTR is the reverse query for lookup. So, here what is done is that an IP address is given and the domain name is found out. Okay. So, this is the, just as you have ARP and RARP, similarly you have query and reverse query. So, reverse queries are used as a weak mechanism to avoid spoofing. I mean, this is weak. For example, those machines, a machine may have a name, but say if it connects to the network through a modem, in which case it may be given an IP address dynamically, then sometimes it may not get reflected, etc. So, SendMail uses an identity message to identify the sender and receiver, but as we have seen, or as we will see later, that this can easily be spoofed. Some mail servers do not forward mail if you are not in the domain, so it will not forward mail. So, this is for anti-spam. Spam, you know, are mails which are sort of spuriously generated by people, or mostly by programs or machines which are automatically generated and sent to millions of people. So, your mailbox gets filled up with spam. It has been estimated that a majority of the mails which go through are actually spams, and you do not want that. So, so this one weak way is to that if the mail is not for my domain, I am not going to relay this to other mail servers. Sometimes you can do that, but sometimes you have to relay, because it is your responsibility to relay. And does not accept mail if it can reverse query your IP address. That means, so as soon as a mail comes, what it will do is that it will find out from which IP address this mail is coming, then send a reverse query, and if the reverse query, by the reverse query the name looks responsible, maybe it is coming from some known university, etc., etc., then we accept the mail. If it is, if you cannot reverse query it, then maybe it is coming from some spurious source, and it does not accept. But as I mentioned that this is just a very weak this thing, this is not totally secure, because host on same physical network can always spoof IP headers from of domains which are sort of respectable. But anyway, this may be of some use. Now, who manages the in-address ARPA space? So, when you get a portion of the IP space, you also become responsible for handling the queries. So, this is why queries are in reverse order. Okay. So, that is a small point. Finally, dynamic DNS. So, DNS maps domain names to specific IP addresses. This requires that each domain name is statically assigned, since the zone table is typically stored on disk. This implies that a host using a dynamically assigned IP address means you connect to that host. So, this is what dynamically, whether the dynamic DNS is possible or not. Okay, so that is not widely implemented, but that it has, there is an RFC for this, and it uses a secure connection. Now, for doing a dynamic DNS, what you have to do is you have to sort of update the name server database. And this name server database, of course, I mean, that's just anybody cannot go and change the name server databases. So, you have to use a secure connection to update the DNS database. Okay. And next we take up a topic of directories. This is well, in some sense somewhat similar to somewhat similar to DNS, but more general. Actually, the directory sometimes uses DNS, but that is a different issue. So, directory, the idea of the directory is that, for example, I mean, many of you have used mails and using clients where you have your own address book. Okay. So, in the address book, so to those persons who had sent you mail or to whom you usually communicate, their names will be there. So, you can look up the email address from the address book. This is, I mean, say one example of a directory service could be some kind of a global address book. Okay. So, I can find the email address of anybody from that global address book. This was the original good intention, but of course, those people who produce spam mails, and they have sort of killed this idea. So, nobody wants his email address to be in a directory which is universally available, so that everybody will send all kinds of junk mails to him. But anyway, directory can be used for many other purpose, and we will just skim through this quite fast. So, what directories are? In general, they are object repositories, and typically read more than they are written, have explicit access protocols, and support relatively complex queries. DNS queries are simple, but it supports relatively complex queries. For example, you can say theoretically have something like that. Give me the email addresses, assuming that email addresses are still available, that email addresses of all people who live in Delhi, whose name contains Ram. Okay, so you can have an address. Maybe you are looking for somebody, all right. So you can have more complex queries than you can have in a DNS. So you can have all kinds of things in a directory. And but of course, directories are not meant to be RDBMSs. They are just for looking up. So they lack notion of tabular views, join operations, etc., or stored procedures. So they are not regular RDBMS. They are just for this particular service. Now, X.500 was the originally how directory was envisaged by the telecom industry. So, goal was to have some global white pages, look up anyone, anywhere, and developed by telecom industry ISO standard using for OSI networks. So, idea was a distributed directory. Application uses, just like you have distributed DNS and name server, similarly you have a distributed directory structure. Application uses directory user agent to access a directory access point. So, the picture is something like this. You have a directory user here who uses a directory user agent, which in turn connects an access point to the directory. Now, how is the names used? To access resources given the name, build a name to find a resource, information about resource. So, these are the different uses of names. Now, only programs look at these names? So, sometimes humans also need to use the names for construct the names, recalling names, Now, is resource static? This is a point that sometimes resources may move. So, change in a location may change the name of a particular resource. So, and performance requirements are also there, it has to be in human scale. Now, the directory information base, which is defined in X501, this is given as a tree structure. Root is the entire directory, levels are groups, for example, country, organization, individuals, and entry structure should have a unique name built from tree, attributes, type, and each attribute would be a type value pair, and schema enforces type rules, and there may be alias entries also. So, a directory structure might look something like this. You have these different levels which starting from the top may represent some organizations and then some sub-organizations, and finally you have the objects. Now, in an object entry, so the entry will have some names, and each of these names would have a series of type value pairs. So, there may be more than this attribute, one particular name may have a number of attributes, and each attribute will have a type value pair. So, this is the general structure of an X.501, that is the tree structure. The queries to this system are defined in X.511. Query is a read, get selected attributes of an entry, compare does an entry match a set of attributes, list children of an entry, search, abandon request, etc. So, these are all kinds of queries are possible. And modification, you can modify these records, add, remove, modify entry, modify distinguished names, etc. So, these are also there. Then there is a directory system agent. It may have some local data, can forward requests to other system agents, can process requests from user agents and other system agents. So, these are like your the name server system with resolvers and all. So, this is the system using directory system agents which can do the query processing. It may get the data locally or it may forward the request to other systems. Referrals, if a DSA cannot handle the request, can make request to other DSA, just as you can make iterative and recursive queries in DNS, or tell DUA to ask the other DSA. This is the iterative version. Directory information can be protected, actually they are usually protected. So, there are two issues here. One is the authentication, which is defined in X.509, and the other is access control, the other is X.501. So, actually this a directory by itself does not give you security. So, you have to have more, you have to have more other components in order to ensure security, but a directory can be used for some authentication service, for some security purpose, etc. Directory can very well be used, and they are actually used that way. We will just talk just a little bit about security towards the end. Standards specify basic access control, and individual DSS can define their own access control, that whom they are going to allow access to their local databases and whom they won't. And replication, this is defined in X.525. Single entries can be replicated to multiple DSS. Once again, just like you have a primary name server and then you have a number of secondary name servers, similarly you can have a directory in a primary or master, and then you can have replication there. So, two replication schemes, cache copies on demand or shadow copies which are agreed in advance. From time to time there is a transfer. Copies required to enforce access control. When entry sent, policy must be sent as well. So, modification is done at the master only, and copy can of course become out of date, etc. So, how to handle that, all that is defined in X.525. And then there are a number of protocols which are defined in X.519, directory access protocol. That means here the structure of the query and other things would be defined. Directory system protocol, request response between DSAs, directory information shadowing protocol, DSA with shadowing agreement, directory operational binding management protocol, and so on. There are a number of protocols. We need not really go into the details of this. And uses is of course for lookup, attributes, not just distinguished names or context. Humans can construct likely names, and from this browsing, yellow pages where aliases also may be given, and search restriction and relaxation may be there. Groups may be defined, that means having a number of members who will be having their own attributes. Authentication information that may be contained in the directory, and so on. So, there may be directory may be used to various uses. Now, we come to LDAP, which is the lightweight directory access protocol. Actually, like since this was designed by the same people who designed OSI, so this X.500 actually tends to be a little complex, alright. So, complex, it is heavy, and it uses the OSI layer, all the 7 layers. Now, for the internet people, internet purpose, actually which uses the TCP IP stack rather than the 7 layer OSI stack, there was a lightweight directory access protocol which can or interoperate with this X, at least on one side, that LDAP can use that X.500 directory service. But this is much simpler than X.500, and LDAP is used in many places. So, this is a lightweight directory access protocol, supports X.500 interface, does not require the OSI protocol, this uses the TCP IP protocol. So, this is X.500 for the internet crowd. Useful as a generic addressing interface like Netscape address book and so on. The LDAP or lightweight directory access protocol is a networking protocol for querying and modifying directory services running over TCP IP. And LDAP directory usually follows the same X.500 model which we have discussed. Now, it is a tree of entries, each of which consists a set of named attributes with values. An LDAP directory often reflects various political, geographic and or organizational boundaries depending on the model chosen. And when you do that, you can also define your security policies based on this directory and based on this boundary. So, you can do that. Authentication service specially. So, a directory is a tree of directory entries that we have seen. An entry consists of a set of attributes and attribute value pairs, and the attributes are defined in a schema. So, this is the this would be the protocol stack for LDAP. So, you have a directory based application, okay, maybe some authorization service or maybe some access to some information which may be there for the organization, which uses LDAP. LDAP may use TLS. This TLS is transport level security. So, transport level security, actually you could use SSL also. Actually, I am talking a lot about security here. We have not discussed security, so we will in future we will sort of give one lecture to security, because this has become so important. Now, in an organizational context, a directory may be an important component of the entire security arrangement. Security is a complex issue, but anyway, for this LDAP we require that we communicate securely in many cases, and many LDAP implementations support the start TLS, that is a transport level security, or you can use SSL also or SASL, and all these use TCP, and of course TCP sits on this IP which sits on the other layers, etc., etc. So, it comes in between the directory based application and the TCP layer. That is where it stands in the protocol stack. We mentioned some of the operations which are there in LDAP. I will just mention them. Say bind, authenticate and specify LDAP protocol version. this actually starts the process. Start TLS, protect the connection with transport layer security to have a more secure connection. Actually, I mean, since you are giving some access to information, you want to put some security features in there. So, that is the start TLS. Search for and or retrieve directory entries, that if I mean if you have access, that means if you can go through the access control, you search for some records. Then compare, test if a named entry contains a given attribute value. So, you can compare, you can add a new entry, you can delete an entry, you can modify an entry. So, these are the various LDAP operations. Modify DN, move or rename an entry, okay. And then abandon, abort a previous request. Extended operation, generic operation used to define other operations. And unbind, that means close the connection. So, this is not exactly the inverse of bind, but anyway this is to close the connection. So, these are the roughly some of the operations in lightweight directory access protocol, and just we will just touch on this security issue. Notion of security for a network protocol is comprised of at least 3 axes. You see, one is the identity and authentication. Who are you and who says so? So, you have to identify yourself, and then I mean it should have some protection against spoofing, that somebody claiming to have an identity which is false. Confidentiality, that means whatever information is being passed around, it should not, I mean other people should not be able to snoop into it. So, confidentiality is important. So, usually I mean you might use some kind of encryption for this confidentiality purpose. Integrity, did anyone muck with this data, that means did anyone change this data. So, if there is a change which has been done by some person whom I mean who is authorized to do that, you might want to keep a log or audit trail for such changes, or otherwise you want to be sure that on the way somebody has not changed this data. So, it may be necessary for some application. So, in which case you want some kind of a signature kind of thing to see that whether the data has not been changed. Authorization, yes you can do that, but no you cannot do that other thing. So, that means there is some authorization and access control which are also. So, these identity, confidentiality, integrity, authorization, at least these axes are definitely there. So, one needs to separately consider each of the 4 security axes in the context of anticipated threats. Also need to consider security from the perspective of information stored in the directory and attributes of the request. Okay. By the way, data security is not equal to access security. We will talk more about security in one separate lecture by itself. Here I am just mentioning it, that some typical security features of LDAP implementations. So, simple password based authentication there, SSL on a particular port, that port 636, or SSL is secure socket layer, and TLS is transport layer security. This is on port 389. There are some access control and there are some configurability. So, we have just touched on this security aspect. There are other things that you can do with a directory, especially in the context of an organization. Because of spams and other issues, the idea of actually generating a very global white pages for everything under the sun, such a grand idea did not really work out. But in the context of a specific organization with its own security boundary and its own needs etc., which are well defined, LDAP is a protocol which can be used. Thank you.